A short-range complaint does not identify a failed battery component. The same symptom may come from the charger, wiring, connector, battery management system, a weak module, an aging pack, or a temperature-related condition. For an e-bike or scooter service center, the risk is releasing or replacing a returned pack after a single voltage check, without enough evidence to support the decision. The workflow begins with intake and safety triage. Record the customer symptom, battery identifier, vehicle application, charger type, visible condition, initial status, and any reported overheating or impact. Packs showing damage, swelling, leakage, abnormal heat, or unsafe connectors must be isolated before an electrical test is considered. The intake record should preserve the difference between a customer complaint and a technical diagnosis. Before connecting a tester, define the decision the test must support. The approved procedure should identify the relevant pack family, voltage and current conditions, cutoff rules, connection method, operator, review owner, and data retention requirements. It should also state who may change the test profile. This keeps the result tied to a controlled service process instead of treating a published equipment capability as proof of suitability. A repeatable charge-discharge profile makes results comparable across returned packs. The record should include the charger context, test settings, curve or report location, observations, repair action, reviewer, and final disposition. A bench result is not sufficient on its own. It must be read alongside connector inspection, BMS behavior, reported heat or impact, and the original customer symptom. A practical selection review can consider a system such as DK Testing Equipment's DSF 4099V 40A lead acid and lithium battery pack charge-discharge tester. Its stated voltage range, current settings, panel and software operation, curve-related functions, and protection features should be assessed against the service center's return pack population, fixtures, repair authority, and safe hold procedure. The equipment should be demonstrated with representative e-bike, scooter, or light electric vehicle battery packs. Buyers should verify the approved settings, connection arrangement, visible result, and exception path when a test does not follow the expected pattern. The workflow should give priority to intake condition and identification, safe connection and setup, controlled charge-discharge evidence, report completeness, and escalation discipline. Safety checks come first. Confirm the pack identity, polarity, connector and cable condition, temperature, visible damage, and authorized profile before energizing. A charge-discharge system supports an approved process. It does not authorize an operator to bypass isolation, qualified handling, or escalation. After testing, connect the evidence to the repair decision. If a repair is performed, retest under comparable conditions to determine whether the controlled result changed. A component replacement is not proof that pack performance has been restored. Conflicting results, unexplained BMS behavior, abnormal heat, damaged housing, repeat returns, or conditions outside technician authority should trigger engineering review, safe hold, qualified end-of-life handling, or another defined escalation route. The service report must travel with the battery. A later technician should be able to see what was measured, which profile was used, what stopped the test, what repair was performed, and why the pack was released, monitored, held, or transferred for review. Consistent naming, protected retention, and a clear disposition owner make the record useful across locations and prevent repeated incomplete diagnosis. A service result has a defined boundary. It can support the next workshop action when the battery identity, test profile, and observed stop event are clear. It cannot independently authorize transport, recycling, or a promise about future range. Those decisions require the service center to apply its relevant safety, warranty, and operational rules. The objective is a documented sequence: triage, controlled test, repair or escalation, retest, and disposition. When every step is traceable, technicians can act on comparable evidence instead of assumptions, reducing repeat uncertainty and unsupported replacement decisions.